So the second one we're going to talk about is reflections, which again is on that note sheet that I gave you. So we're going to fill in these tables and then graph these on the same axes. Okay, so I'm going to look at the square root of x. So again, if you forget what it looks like, we're going to put our table. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Okay. And then I'm going to do negative square root of x. So that would mean I have negative the square root of 0. Again, square root of 0 is 0. 0 doesn't have a sign. So whether it's negative or positive, we just put 0. Okay, negative the square root of 1. I would still have the negative, and then the square root of 1 is 1. Negative the square root of 4. So again, these are my x values that I'm plugging in to this function is negative 2. Okay, so I'm going to graph both of mine. So in blue, I'm going to put f of x. So it's 0, 0, 1, 1, and then 4, 2. Okay, and remember square root makes like half a parabola there. Okay, so then we have negative square root of x. Okay, so I'm going to graph these x values with these y values. Okay, so pretend like this table's not the middle there. So I have the point 0, 0 still, but now I have 1, negative 1, so 1, negative 1, and now I have 4, negative 2. Okay, and so this is my new graph. This is the graph of negative the square root of x. And this is the graph of the square root of x. So if we look at it, what happened? Well, all of the y values are opposite signs. So they were positive, now they're negative. And so what that does is it flips the graph over the x-axis, okay? And that's called a vertical reflection. So when I have g of x equal to negative f of x, it's going to flip graph over x-axis. Okay. And that's called a vertical reflection because you're reflecting it up and down, which is vertically. And so it changes the sign of every y value. Okay, so if your y value is initially negative, it will become positive. It will flip up to the first quadrant. And if it's positive, then it will become negative. Okay, and that is called a vertical reflection. And if you're going to put this is y g of x equals negative f of x. That's usually how we write it. Okay, so then we're going to look at horizontal reflections. So horizontal reflections are going to look like in the form where it's f of negative x. So the negative is going to be inside the function. So again, my parent function is the square root of x. Okay, if we have the negative outside, which would be here, is what we just looked at, that vertical. If we have the negative inside like this, we're going to explore that one here. So we have, we're going to plug it in here. So I changed the x values. I have negative 4 and negative 1, 0. So I'm going to do f of negative 4, which would be the square root of negative 4. Okay, so I still have that negative. I'm putting in this negative 4. You can put parentheses, you don't need them. So the negative of a negative is a positive, and so I have the square root of 4, which is just 2. Then I have the square root of negative 1, which is the square root of 1, and then just the square root of 0, which is 0. So if I graph this graph, I have negative 4, 2, negative 1, 1, and 0, 0. So it looks like this. So my original graph square root, remember, looks like 0, 0, 1, 1, and 4, 2. You can look at that table that's right next to yours from the slide before. This is the graph of the square root of x. So notice this one we say is reflected across the y-axis. It's flipped across the y-axis. So you could say flip or reflected. And what happens is if I do x and f of x equals the square root of x, what happens is the y values don't change, but the x's change sign. So when y was 1 initially, with the square root of negative x, x is negative 1. But for the square root of x, when y is 1, x is positive 1. So it changes all the signs of the x values. It flips the x value signs, but the y values stay the same. And so when we have g of x equals f of negative x, it reflects, okay, or flips graph over the y-axis, right? And it's called a horizontal reflection. Because we're flipping it left and right, which is horizontal. So this reflects it over the y-axis. Okay, so again, a summary, explain the following transformations. If we have negative f of x, it reflects flips the graph over the x-axis. And again, it's called a vertical reflection. And if the negative is inside the function, we reflect, flip the graph over the y-axis, which is called a horizontal reflection. Okay, so those are our reflections when we have the negative. Okay, so one thing to note is that horizontal and vertical shifts and reflections, which are all the ones we just did, don't change the shape of the function. It just shifts it some way. So shifts and reflections are therefore, they're called rigid transformations. They stay the same shape. We're gonna do the next ones, which are called stretches and compressions. That's what we're gonna do next. And they will change the shape slightly, okay? And they are not rigid transformations. So let's look at the stretches. So we have a function a times x squared. Okay, so we're gonna have a number outside of the x squared like this, 2 times x squared, and that again is considered outside. So we're gonna look at what happens when a is greater than 1. So in this case, we're gonna graph x squared again, so I'm gonna quickly fill that in. Again, I'm just squaring each of these. Okay, now I'm gonna do 2x squared. So I'm gonna do 2 times negative 2 squared. Negative 2 squared is 4. 4 times 2 is 8. Plug in 1 to this function and I get 2. Plug in 0 and I get 0. 1 and I get 2. Plug in 2 and I get 2 squared, which is 4 times 2, which is 8. Okay, and so just notice each of these y values are multiplied, the original y values are multiplied by 2, because I'm squaring it and then I'm multiplying by 2. Okay, so I'm going to graph both on the same axis. So x squared right? And then I'm going to graph g of x in blue. So I have my x value is negative 2, but now I'm at 8. my X value is -1, but now I'm at 2. 0 did not change, because 0 times anything is still 0. When it's at 1, it's at 2. And when it's at 2, my Y value is at 8. So I'm going to go 2 over up 8. And so what we can see is that all the Y values like doubled. So the X value is the same, but the Y values doubled. And what we call that is a vertical stretch. We're stretching it up towards the Y axis. So when A is greater than 1, it stretches vertically. And we say by a factor of A. And so what we're really doing is we multiply each Y value by A. Okay, and again, we keep the X value the same. So that's when A is greater than 1. Okay, but what happens when A is not greater than 1? So when A is between 0 and 1, and we say it's greater than 0 because if it's less than 0, then we're going to have that flip or reflection. But we're going to look at, okay, what if it's like 1/2? So we're going to do the same thing. We're going to graph it. So again, I'm going to quickly plug in X squared because it's the same as we've been doing. But now I'm going to do 1/2. So again, I'm going to do 1/2 times like -2 squared. And -2 squared is just what we get here, 4. So we're going to do 1/2 times 4, which is 2. 1/2 times -1 squared, which is 1 times 1/2, which is 1/2 or 0.5. Again, 0 squared is 0, and anything times 0 is 0. And then if I plug in 1, I again get 1/2 or 0.5. And if I plug in 2, I get 2 squared, which is 4 times 1/2, which is 2. So again, I'm just having each of these Y values here when I'm multiplying it by 1/2. So graphing my original. So this is Y equals X squared. And now I'm going to graph my 1/2 X squared. So when X is -2, Y is 2. When X is -1, Y is 1/2. So we're just going to go halfway. Kind of hard to graph. 0, 0, still there. 1, 1/2. And 2, 2. So what we call this, when A is less than 0, we call this a vertical compression. Okay. Which means like all the Y values are being compressed down. Okay. And so we take, again, we're taking 1/2 of each of those Y values. So what initially we were 4, we take half of 4, so now it's at 2, but the X value stays the same. When it was at 1, we took half of 1, which was 1/2. Okay. And again, we're doing the same thing. We're multiplying all our Y values by A. Okay, but in this case, again, A is going to be a fraction less than 1, and so it's going to make the Y value smaller, which is compressing it closer to the X value, X axis. Okay, and so that's what A does if it's less than 1. So if we have A times fx, and this should be A is greater than 1, not A is greater than 0, A is greater than 1. If we have that, our f of x is vertically stretched by a factor of A. And that's what we said on the page before. And if it's from 0 to 1, we say f of x is vertically, we call that a compression vertically compressed by, again, a factor of 1 over A. But for both of these, what we do is we multiply, sorry, not 1 over A, by still compressed by a factor of A. It's just A is going to be like a fraction again. Multiply Y values by A, and then again, this one, we're going to multiply Y values by A. But because this A is less than 1, it's going to like shrink the Y values, which is compressing them. And then this one is going to make the Y values larger, so it's stretching them. Okay, so the last one is horizontal. And again, this one is backwards of what we think. So we're going to explore when you have BX. In this case, B is between 0 and 1. So again, it's going to be a fraction between 0 and 1. So we're going to do the square root for this one. So square root of 0 is 1, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. And I'm going to do these on 2 separate graphs so we can compare them. So this is the square root normally. Okay, so what happens if I do 1/2 inside? So h of 0 would be the square root of 1/2 times 0. 1/2 times 0 is 0, that's still 0. So we have the point 0, 0. Okay, if I do 2, I have the square root of 1/2 times 2. 2 times 1/2 is 1. The square root of 1 is 1. So I have the point 2, 1. So remember, this is 1, 1. Now I have the point 2, 1. If I do 8, well, sorry, I need to make this bigger. Square root of 1/2 times 8. 1/2 times 8 is 4, and the square root of 4 is 2. So I have 8, 2. And then 18. The square root of 1/2 times 18. Half of 18 is 9, and the square root of 9 is 3. So I have 18, 9. Okay, so this is 16, 17, 18, and then 3. Okay, so we had 2, 1, 8, 2, and then 18, 3 on this graph. And this one I have 1, 1, 4, 2, 9, 3, and 16, 4. Okay, so what happens is, notice my Y values, okay, I still have a 3, I still have a 2, I have 1, 3, 2, 1. But my X values are all double. So initially X is 1, now it's 2. Initially X is 4, now it's 8. Initially X was 9, now it's 18. And so when it's 1/2 inside, it actually does the opposite. It stretches it. So when it's less than 1, it stretches. So G is stretched by a factor. And what we say usually is 1 over B. Okay, so for this one, B is 1/2. And if we do 1 over B, which is 1/2, what we can do is when we do fractions, we multiply by the reciprocal. So it's 1 times the reciprocal 2 over 1 is, sorry, 1 over 2 is 2 over 1. And that gives me a 2. And so it's stretched by a factor of 1 over B. And so really we can just like multiply by whatever the number is in the bottom. That's the easiest way to think about it. So even though we say like B is 1/2, in this case, we can really just multiply by that number. So if I more say it as like f of 1 over, we're going to just use a different letter, 1 over cx, we would multiply x values by c, whatever's in the denominator. Okay, and that is the horizontal stretch. Okay, so again, it's backwards of the vertical one. Okay, so the last one is when b is greater than when like 2 of x. So I'm going to do square root of 0, 1, 2, 3, 4. This function. Okay, so if I do 0, I have the square root of 2 times 0, which is 0. The square root of 2 times 0.5. 2 times 0.5 is 1, and the square root of 1 is 1. The square root of 2 times 2, which is the square root of 4, is 2. And the square root of 2 times 4.5 is 9. The square root of 9 is 3. And the square root of 2 times 8 is the square root of 16, which is 4. Okay, so we're at 0.51, 2, 2, 4.5, 3, and 8, 4. Okay, and so we look at this one. If we compare the x values, so all these y values are the same. If we compare the x values, they're all half of it. Okay. But in this case, b was 2. So again, we're going to do the same thing. We call this a horizontal shrink. And it shrinks by a factor of 1 over b. Okay, so it's 1 over 2, which is 1/2. Okay, and so we would multiply all the x values by 1 over b. So again, it's opposite of what we think. So kind of a real quick summary of it is when b is, and again, this should be greater than 1. So when b is greater than 1, it compresses the graph horizontally by a factor of 1 over b. So we multiply all the x values by 1 over b. And if b is between 0 and 1, then we stretch the graph horizontally by, again, a factor of 1 over b. And so we multiply all, again, the x values by 1 over b. And so that's the last one that we're doing, this horizontal stretches.